Hello YouTube world, this is Logic Crazy and here's yet another tutorial on creating a chess engine in Java. In this tutorial we're gonna complete this flipboard method. We had quickly written it just to show that we needed it, but we haven't actually made this flipboard method flip the board. So when these are called in alpha beta, the board is not actually flipped. And these flipboard methods are put there very strategically. What you want to make sure is that you don't flip extra. You want to flip every time that the other side needs to make a move, but you don't want to flip twice in a row or something useless or extra, or flip when you shouldn't. So the locations of those are important, but I believe they're fairly straightforward as well. And how do we get this board to flip over? Let's first look at the representation. We have lowercase and uppercase. Now, when this board is flipped around, you'll notice at the bottom there'll be a lowercase a and a lowercase q, since everything else is symmetrical, but these center two, in a sense, flip around. So this would be a lowercase a, lowercase q, and uppercase a, uppercase q. And you can just imagine flipping it around, but it's really a two-step process. First, we have to reverse it. So what we're going to do is have a for statement that will go through half of the pieces, that's roughly there, I think, half of them, and trade them off with the opposite piece. So this R will switch with this opposite corner, and then the K with this K, and the B with this B. No matter what's there, it's going to swap. It'll swap through all of them, and you only go through half. If you go through all of them, you end up swapping them and then swapping them again, and you end up with the same starting board. So it's important to have a for loop that only goes through half of them, and that will be part of what we do here. So let's start that. That's only step one. Feel free to come up and think with step two might be, but we're going to start by programming this in right now. Well, actually, let's talk about the second part. Sorry about that. I think it would be wise. The second part is, when you flip the board around, this swapping literally flips the board around, so that lowercase are down here, uppercase are up here. But we have to remember that when it does make move, when it makes a move, or when it figures out what moves need to be made or can be made, it always looks at capitals. And so when we flip it around, it's still going to look for the same side capitals, except it'll think that pawns can't move further up and so on, because they're being blocked by the other pieces and stuff. So what we have to do is not only flip it around, flip it upside down, and also change the case, so that this bottom part here will again be capitals. So that now, instead of this being a lowercase a, this is an uppercase a, this would be an uppercase q, because we flip it around and change the case, so that it always is dealing with capitals. So basically, you could think of it as a regular board, turning the board upside down, and then changing the colors of all the pieces is the process, because this engine has been made, is it move generation and everything, to think for white. So when it thinks for the other side, you turn the other side into white, in a sense, or capital. So let's work here on this flipboard. How do we do this? Well, the first thing we need to do is have a string temp, because you have to realize that when you swap two pieces, let's say you're swapping this one and this one down here, what you have to do is store this one as a temp, and then write in this one a lowercase r. But see, now we didn't know that it used to be a capital R, and that's why we stored it in temp. And then we write this one as whatever temp was, which is a capital R. And then we swap case, of course. So that is why we need to store as a temp. We can't do a swap at the same time. You have to remember what you overwrote, what was overwritten, and then put that in at the other spot. All right, so we're going to have a for statement. And remember, we only go through half of them. For int I equals 0, and then we have I is less than 32. Not less than or equals. Less than 32, I plus plus. All right. Here's our nice big for loop. And let's create this. We were going to say, this is, integer, sorry. R equals I divided by 8. And then we can put a comma. C equals I modulus 8. Now, I might have explained this before, but when you're declaring several integers or several of the same primitive data type, you can just put commas and just so that it's making an integer R and an integer C. All right. Now, we need to put a little if statement for the character. And here's how you find out if something's uppercase or lowercase. And probably discussed this already. Actually, let me see. Yes, and see this whole int R equals I divided by 8 and I modulus 8. We did that in the move, possible move generation. That's the same thing we're doing here. And it's instead of just calculating this a million times, we just store it as a variable and speed up the engine, hopefully. All right, if character dot is uppercase, and this takes in a character, not a string. And then we put in chessboard, and then RC dot, and even though it's one character long string, we still have to say character at 0. And this returns a true or false. So I don't have to write equals true. That's just, it returns true or false on its own. So if it's uppercase, then we store the temp equals chessboard RC dot to lowercase. Remember, we're switching. So if it's upper, turn it to lower. And then else, because we know then it's the other case, just going to copy this. Then temp equals to uppercase. So now we store temp as the reverse. So we can just put in temp directly in the other one. Then, if, I may as well just copy. I'm just going to copy this whole above if statement because I'm lazy. There we go. So if uppercase, but now it's, how do you get the opposite corner? So if we're talking about this one, how do we get this other K here? Well, the answer is, it's 7 minus in the row and column. So this is, for instance, it is column 0, 1. So it's 7 minus 1, which is 6. So 0, 1, 2, 3, 4, 5, 6. And you see we get up in the K, and the same applies for the row. So what we're going to pop in here is, instead of RC, we put in 7 minus. Just going to copy that, 7 minus. So if that's uppercase, then we actually set the regular, the one that we recorded. See, we recorded it as temp. So we set that, we can overwrite that recorded one and still know what it used to be. So RC equals, let me copy this, equals the 7 minus 1 dot 2 lowercase. There we go. And this one, otherwise it's 2 uppercase. And then, of course, right at the end, we have to say, copy this, whoops, there, oh yeah, dot, or sorry, equals temp. There we go. Equals temp. Now that is changed. But there is, if you think about it, one other slight problem. Remember this. Remember where we have to store king positions, C and L. Now why do we store those two? Well, it's to check if the king is safe. For this king safe, we need to know where the king is to know if that position is safe. And when we make moves, we have to adjust where the king is if it happens to be a king that moved. And I do not believe that we recorded that info yet. So that was technically incomplete. And I didn't think about it at the time, but let's change this also for the flipboard, because when we flip the board around, we have to realize that the locations of the king position and C and L need to switch. So after this whole for loop, because we don't need to be doing this multiple times, we're going to say, this time we'll make an int, and we'll say king temp equals king position C. How's that? And then king position C equals, and how do you get the opposite? 63 minus king position L. And then king position L equals king temp. I believe. It equals 63 minus, sorry, again, the 63 minus. Now, why would I have this 63 minus? In these others, in switching the array around, we had this 7 minus when grabbing opposites. And that's kind of the same idea that can be applied here. Say the position C is at 0. This position C is at, let's pretend the capital A was right here at 63. Now when we flip it around, this obviously becomes wherever the becomes the L, but it's 63 minus what is 63, which turns into a 0, and that is true. It bounces over here. So that is kind of why I'm using this 63 minus feature there. So that is it. Yes, if I were just to swap them, as in L is, or the C capital position is at 1 or 0, and the lower is at 2, let's say. 0 and 2. You need a space in between or it's illegal position on the board. So 0 and 2, if I were just to swap them, I would say it's 2 and 0. But that leaves them still here. And we realize that when we flip the board, they end up way, way over here. So that's why you need a 63 minus. You can't just swap them. So hopefully that makes sense. So that's how you swap the king positions there. Now let's update these make moves a little bit, just to make them proper. And we're gonna, let's see. Yes. Now when we update the make moves, we only have to update the position of C, because we only ever move capital pieces. So I need a little if statement here. And we know it doesn't happen in pawn promotion. So I can actually put the if statement inside here, so it's not always checked in those cases of pawn promotion. So what we'll do is, let's see. Now it matters if you do it after the move or before, because if you do it after, the king position is different. If the king indeed was moved, then it wouldn't be. So we're going to put in an if statement here. I keep putting these square brackets there. There we go. Now, if A dot equals, and let's see what this equals is. It would be, well, let's just copy this whole thingy here and modify it. That looks like it'll be easier because I think this is what I need. And it would be 2, 3, just like that. Make sure you have character at 2, character at 3. If A dot equals that location, yes, because that is the new location where the A goes to, if it happens to be moving an A. And it'll be a capital A, so you make sure this is capitalized. Case always matters here. In that case, then we're going to put in king position C equals, now let's again copy all of this, everything inside the brackets, the semicolon. Instead of these square brackets, I'm going to do a plus. Now this is needs to be multiplied by 8. So it'll be 8 times that, and then plus the horizontal. So 8 times row. So if you're, you're 2 rows down, or 0, 1, 2, then you times that by 8. And get 16 plus however far you are over. So if you're all the way at 7 over on the far right, you add 7 to 18, 25, and that's your position. So I believe that is correct. And now, of course, we have to do one more of these. I'll copy this whole if statement, and this is for the undoing a move. Now, let's see here. Undoing a move, same position here. There, inside this not pawn promotion zone. But now we have it not equaling, we're not checking actually at 2 and 3. We should check at 0 and 1. Yes. And then also this should be 0 and 1. And I think that that is all that needs to be adjusted. And of course, we're not checking for king and pawn promotions because pawn promotions never have a king's move in them. But we will need to include this for things like castling, which do involve a king. En passant, we don't need to have it. So we're going to need to, when we add in those features, we'll be careful to do it correctly. All right. So there we go. There's make move and alpha beta. We'll run all this. So here's alpha beta. Let's see here. Instead of just printing out alpha beta, what I'm going to say is make move alpha beta. So it'll actually make the move that the string returns. Now remember, alpha beta returns the move and then followed by a score. But we can still send the entire thing. We don't have to just grab the 4 first characters because make move only deals with the first 4 characters. It actually grabs that 3rd character. That's the furthest character it grabs from the left of the string. Let's take a gamble and see what happens here when I hit run. Aha! Notice this. It ran alpha beta and it made this move right there. Now, obviously we know that this is a failure of a move for a beginning opening. Most chess players will know that. This is, you never really want to move your side pawns, either of them, I would say, in an opening at all. Just don't even contemplate that. But we have to remember, why did it pick that one? Well, we have a rating function, but remember the rating only returns 0. So every move is equal, and it just picked the first move that it saw, or whatever. So That's why I picked a terrible move, but we can see that obviously, especially if I ran make move, if I just put a stopper there and now ran it, you'll see it runs and it runs. I can keep tapping this, but it's doing a ton of making moves and obviously undoing moves. So when we see that the output, I'll just stop this here. When we see that the output here has just one piece moved, we know that we have done a good job. It's made a whack of moves, but it's made moves, flipped the board, made moves, flipped the board, but it's undone them and unflipped the board, so to speak, and only one piece moved, so that's a huge accomplishment. Also, take a look at the number of lines you have, nearly 500. I'd say you're about half done making this chess engine, and the hardest is behind you. So a pat on the back and a congratulations for getting this far. Until next time, enjoy Java.